Hi everyone, this is Mr. Zhang, and today we'll be going over the math homework for Class P. This is for session U2. Alright, for question number 1, which of the following must be equal to 30% of x? So you have to look through all of the following expressions and you have to change the word sentence into a number sentence. So the keyword here is percent and of, what the keywords are. So 30% of x, you're going to have to turn this phrase into a number sentence. This percent symbol here really means divide by 100. So 30% is really 30 divided by 100. You can write this as either a fraction or a decimal. Now, if you look at all the choices, they're all in fractions, so we'll probably have to write the fraction form, which will be 30 fraction bar, literally over 100. But you can also turn this into a decimal as well. If you do long division and do 30 divided by 100, you'll get 0.30 or just 0.3. Either way is fine. In this case, we'll use the fraction form because all the choices are in fractions. And now the next part is this keyword of. Of always means multiply. So you'll have 30 over 100 multiplied by x. And since the multiply symbol looks very similar to the letter x, you can rewrite this with a little dot, which also means the same thing. So the expression turns into 30 over 100 times x. Now x is a whole number. There's no denominator there, so you can actually write a denominator of 1. And when you simplify this expression, you'll multiply the numerator times the numerator, 30 times x, which will be 30x, and then 100 times 1 will be 100. So the answer is 30x over 100, and you can actually simplify as well. You can simplify all the way back here if you cross out one of the zeros. 30 and 100 has a factor of 10 in common, so the factor of 10 can cancel out. You can cancel out the 0 and divide by 10 for both the numerator and the denominator, and that will give you 3x over 10. And that is choice C. Now, if you look at this expression, 3x over 10, you could write this a couple of ways. Right? So you can see it as written in choice C, but you can also see this as two separate fractions, like 310 over x. You could even have any of these parts split up. So you can have, let's say, 3x times 1/10, for example. All of these are the same thing if you just simplify the fractions. All right, so just know that there are a couple ways to write this expression. So the most common way will be 3x over 10, or you can also have 3/10 of x, where you don't even write the multiplication symbol, but they both are equivalent. So the answer is choice C for number 1. All right, next for question number 2, 2 times 10 to the 4th plus 5 times 10 to the 3rd plus 6 times 10 to the 2nd power plus 4 times 10 to the 1st is equal to. So here, this is just expanded notation. So all you have to do is just use the law of exponents to essentially just rewrite each of these into place values. The 2 is in the 10,000s place. The 5 is in the thousands place. Next up, the 6 is in the hundreds place. And then the 4 is in the tens place. So if you add everything up, you'll have 25,640, or choice E, 25,640. All right, next for number 3, on the number line shown above, the length of yz is how much greater than the length of xy? So here you have a number line, just write what these numbers, what the variables represent. So we know that yz is 5, and xy is 2. And 5 minus 2 is 3. Choice A. All right, next for question number 4. If 2 raised to the x plus 1 power is equal to 16, what is the value of x? So here you have an exponent and you have 2 bases. So on the left side, you have a base of 2. On the right side, you have a base of 16. Now, right now, because the bases are different, it's a non-starter. So the first goal is to get the bases the same. And you can use the laws of exponents to just rewrite the sum of the bases here. So 16, for example, thankfully is a power of 2. Specifically, it's 2 to the 4th power. So if you replace 16 with 2 to the 4th, that's going to help you get started, and then we can use the laws of exponents. So once you replace 16 with 2 to the 4th, do a substitution. You'll have on the left side, it's still 2 raised to the x plus 1. And now on the right side, instead of 16 raised to the 1st power, it's now 2 raised to the 4th power. And now because the bases are the same, you know that the exponents, x plus 1 and 4, have to be equal to one another. So you know that x plus 1 has to be equal to 4 because now the bases are the same. You can make the exponents equal. And now you can solve for the value of x just by doing inverse operations. If you subtract 1 on both sides, you will get that x is equal to 3. And that is choice B. So again, the goal here is to just get the bases the same. Once you get the bases the same, then you can start this problem. Before you do that, though, you can't really do anything. So again, it's really important to get the bases to be the same. Okay, next for number 5, you have this figure not drawn on the scale. On the figure above, what is the value of A? So here you have a whole bunch of angles around this central point. And figure not drawn on the scale means that you can't really compare the measurements of the angles with one another based off of its looks. Again, looks can be deceiving. But what you do know, though, is that a full circle is 360 degrees. So these 5 angles here has to add up to 360. That's a magic number here. And the next thing that we can do is to actually realize that little symbol, that little square, actually means 90 degrees. This little box here. So we can actually come up with an equation now with these 5 angles and how they add up to 360. So if you take A, just going clockwise, plus 90, plus this 30, plus the 2A, and finally plus this 30, that has to be equal to 360 degrees. Now we have to just combine like terms. Here, the A combines with the positive 2A. Remember, if you have just A as a variable, the coefficient in front is a 1, is an invisible 1 there, and 1A plus 2A becomes 3A. That's how you add those two like terms. Now you also have a whole bunch of like terms here, specifically the numbers. You have positive 90, positive 30, and another positive 30. So then when you combine those 3, you have 90 plus 30, or 150. So this turns into 3A plus 150 is equal to 360 degrees. And now you can solve for this variable A just by using inverse operations. If you subtract 150 from both sides, you would get that 3A on the left is equal to 210 on the right. And then here you have 3 times A. Remember, there's an invisible multiplication in there. So if you knew the inverse, or divide by 3, you get that A is equal to 210 divided by 3, which is 70. So A is equal to 70 degrees, which is choice E. Now you can always double check your work. And to check your work, you just have to substitute 70 for A. So that angle is actually 70 degrees. 2A would be 140 degrees. And want to see if everything adds up to 360. So if you did 70 plus 90 plus 30 plus 140 plus the other 30, I want to see if this adds up to 360 degrees. And here, 3 and 7 is 10. And then you have 14. Oops. 9 and 14 is 23. You have another 3 there. So if you add everything up, that will be 36. So this would be 360. So everything does check out. So for question number 5, you have to realize this was a 90-degree right angle. That's what that symbol means, that a little box. And then just substitute the sum into the full circle being 360 degrees. That was the key fact here that you have to use. So full circle, 360 degrees. And then just solve the equation using inverse operations. All right, next for question number 6. A machine labels 150 bottles in 20 minutes. At this rate, how many minutes does it take to label 60 bottles? So the keyword here is rate. And here you have 150 bottles, and that's done in 20 minutes. And you want to know at the same rate, so at the same proportion, how many minutes does it take? So X minutes, and you only want 60 bottles. So you can solve this using proportions, which is what I have set up here, or almost set up. If you just draw your fraction bars, you'll have your proportion once you raise the arrows. The key part is to line up the units. So bottles are over bottles on the left, minutes are over minutes on the right. So everything lines up. Once you set up this proportion, you would just cross multiply. And when you cross multiply, you'll have 150 times X is equal to, here this is 60 times 20. So 60 times 20 is equal to 1200 is equal to 150x. Then if you divide by 150 on both sides using inverse operations, you get that x is equal to 8. So that means that x is equal to 8 minutes. That's choice D. Now the other way to do this question just by using unit rate, and you can also use a different method to check your work. So if you have 150 bottles in 20 minutes, you can find a unit rate here to figure out, well, if you divide 150, let's say, by 5, 30 bottles will take, if you also divide 20 by 5, this will take 4 minutes. And then here you can divide by another 2. So you have 15 bottles. And divide by 2 on the right will take 2 minutes. Now to go from 15 bottles to 60 bottles, you'll have to multiply by 4. So 15 times 4 is 60 bottles. And then on the right, you also times by 4. So 2 times 4 would be 8 minutes. So you know that 60 bottles will take 8 minutes. So that's the same answer as if we solved the proportion. The key here, if you did use the proportions, make sure the units are lined up. All right, next for number 7. If x minus 1 is a multiple of 3, which of the following must be the next greater multiple of 3? So if you want to solve for x, here you can actually have a whole bunch of values for x. So you can just pick a multiple of 3, like 3, for example. 3, of course, is a multiple of 3. And x minus 1 would have to be equal to 3. That means that x would have to be 4. Because 4 minus 1 is 3. So now if x is equal to 4, substitute x in for all the choices. Choice A would be 4, because that's just x. That's not the next greatest multiple of 3. The next multiple of 3 would be 6. Choice B would be 4 plus 2, which is equal to 6, so that's probably it. But just go through all the choices just in case. For choice C, you have 4 plus 3, that's 7, so that's wrong. Choice D, you have 4 times 3, or 3 times 4, which is the same thing. That's 12, and that's too much. And for choice E, you have 3 times 4 minus 3, and that's 12 minus 3, or 9. And that's not equal to 6, so that's wrong. So the answer has to be choice B. So what you can do here is substitute in, make x equal to 4, and then see which one of the choices is equal to 6. Now, the other thing that you can do is if x minus 1 is a multiple of 3, you know that the next multiple of 3, you just add 3 to it. So that's x minus 1 plus 3. And here you have like terms, specifically the minus 1 and the plus 3. Those are like terms. They'll combine and you'll have negative 1 plus 3, which is positive 2. So that's why x plus 2 is always going to be the next multiple of 3. The answer is going to be choice B. Next, for number 8, when x is divided by 5, the remainder is 4. When x is divided by 9, the remainder is 0. Which of the following is a possible value for x? So possible means that there could be many answers for x. So you just have to go through all the choices and see these two criteria if they're true. So if you divide it by 5, you have a remainder of 4. So that's going to be the first thing that you want to do. Divide by 5. So when you do 24 divided by 5, you'll have 4, remainder 4. So that could be it. For choice B, when you do 45 divided by 5, you get 9, remainder 0. So that's wrong because you want a remainder of 4. For choice C, when you do 59 divided by 5, you get 11, remainder 4. So again, that could be it. For choice D, you have 109 divided by 5. That's equal to 21, remainder 4. Finally, for choice E, when you do 144 divided by 5, you have, do a quick division here. But it does end in 4 or 9, so you do have something that's remainder of 4. So it's 28, remainder 4. All right, now the next criteria that also has to be satisfied is if you divide by 9, the remainder is 0. So it has to be a multiple of 9. 24 is not a multiple of 9. It's not a 9 times table. 45 is pretty eliminated. For choice C, 59, you can't divide by 9. 109 is also not in the 9 times table. But 144 is, so that has to be the answer. If you do 144 divided by 9, you'll have 16. So again, here you need both of the criteria, divide by 5, remainder of 4, and divide by 9, remainder of 0, which means it's a multiple of 9. And only choice E satisfies both of these. All right, next for number 9, in triangle ABC, AB is equal to 6, BC is equal to 12, and AC is equal to x. Which of the following cannot be a value of x? So here you're talking about a triangle here. I don't see a triangle, so you're going to have to draw a triangle and just label it AB, triangle ABC. AB is equal to 6, and then BC is equal to 12, and AC is equal to x. Now, x could actually be a whole bunch of potential values, but there are actually restrictions for what x can or cannot be. Specifically, you have to use what's called triangle inequality. So the triangle inequality theorem states that if you have the sum of two sides of a triangle, it must be greater than the third side. So, for example, if you have, let's use different letters actually. Let's have x, y, and z. If you have a triangle with sides of x, y, and z, x plus y has to be greater than z, because the sum of these two sides has to be greater than the third. Next up, x plus z has to be greater than y. Those two sides added up has to be greater than y. Oops. And then finally, y plus z has to be greater than x. So these two sides. So all theory has to be true, has to be satisfied here. So here you can take those two. 6 plus 12 has to be greater than x. Then you can also do 6 plus x. has to be greater than 12. And finally, 12 plus x has to be greater than 6. Now, this last one is actually useless because 12 is already bigger than 6. So when you do 12 plus x, of course, that's going to be bigger than 6. So this one there's no purpose of that. But the first one's important. 12, of course, is 18. So 18 has to be greater than x. So x has to be less than 18. Now, all the choices are less than 18. So that's not that helpful here. But sometimes that will give you the answer. Now, for the second one, though, when you have 6 plus x is greater than 12, you would have to solve for x. And inequality to solve just like regular equations. Whatever you do to one side, do to the other side. You got to use inverse operations. Subtract 6, in this case, from both sides. And on the left side, you have x. On the right, you have 12 minus 6, which is 6. So x has to be greater than 6, but less than 18. So here, all the choices are, less than 18, but choice A is not greater than 6. 6 cannot be greater than 6. 6 is equal to 6. And here we have the weak inequality, which means that it doesn't include the endpoint. So that's important. Here, it doesn't include 6 or 18. And now we can actually do a guess and check as well, because if you try to draw a triangle that is a 6, 6, 12 triangle, we'll see that that triangle doesn't really exist, because if you draw this more to scale, if the base is equal to 12 and this side is equal to 6 and the other side is equal to 6, they can't meet unless you swing both of these points down. They'll meet right on the line, right on the base, because 6 plus 6 is equal to 12. So, of course, that's not a triangle. This is not a triangle. This is just a straight line. So that's why A cannot exist. Same thing would happen if you have 18. It'll just flatten into a straight line. So again, here the key was triangle inequality, which states that the sum of two sides has to be greater than the third side of a triangle. And this works for all triangles, not just right triangles or scalene triangles. It works with every single triangle. All right, and here's the summary for this page. Okay, next for number 10, the average of 20, 70, and x is 40. If the average of 20, 70, x, and y is 50, then y is equal to. So here you have the keyword is average, and average is just, you add everything up and you divide it by the number of data. So it's a total sum divided by the number of data. In this case, the average of 20 plus 70 plus x divided by 3, because you have three numbers, that's equal to 40. So here, if you multiply both sides by 3, you'll get rid of 3 in the denominator on the left, and you have 20 plus 70 plus x, or 90 plus x, is equal to 40 times 3, or 120. Then if you subtract by 90 on both sides, you'll get that x is equal to 30. All right, now we can use that for the second number sentence, which says that the average of 20 plus 70 plus x plus y, this time you're divided by 4 because you have four numbers now, and that's equal to 50. Again, x is equal to 30, so you can replace that with 30. If you multiply everything by 4, and then you'll have to do 20 plus 70 plus 30, or 120 plus y is equal to 200. That's 50 times 4. Then if you subtract 120 on both sides, you'll get that y is equal to 80. And that's choice B. So here we're just using the average formula, which states that the total sum divided by the number of data is the average. So we just have to use that twice to solve for y. All right, so here you have a bar graph. According to a bar graph above, the number of books borrowed during the month of January was what fraction of the total number of books borrowed during the first 6 months of the year? To here, the keyword is fraction. And fraction, remember, just a part over whole. In this case, the part will be the number of books borrowed in January, which, if you take a look at January, again, you just look at the x-axis, go all the way up, and then go all the way up to the end of the bar, and then trace it back to the y-axis. For January, it's 300. So part over whole is going to be January over 6 months. So for January, it was 300. Now for the first 6 months, that includes January as well. So we'll be adding 300 plus the next one is 350, then 400, 450, then 500, and then 400. So you have to add everything up. 350, 400, 450, 500 for May, and then 400 for June. So here we have 10. So that's 6 plus 4 is 10. And then that's 9 plus the 1 is another 10. So that's 24. That's going to be 2400. So your final fraction is 300 over 2400. Cross out the zeros, and 3 over 24 simplifies to 1/8. That is choice A. All right, next for number 12. If 40% of R is equal to S, then which of the following is equal to 10% of R? So here you just have to turn the word sentence to a number sentence. So 40% of R is equal to S means that if you take 40%, or 40 over 100, of means multiply, and you're multiplying by R, is equal, of course, means equal sign, that's equal to S. So here you have this fraction. You can just leave this like so, but you can also simplify it. 40 over 100 actually simplifies to 2/5. So 2/5 times R is equal to S. Now you have to go through all the choices and figure out which one is equal to 10% of R. 10% of R is 10 out of 100 times R, or 1/10 of R. So that means you'll have to turn 2/5 into this 1/10. So you can actually get that by first multiplying by the reciprocal to get R by itself. The reciprocal is an upside down fraction. If you multiply both sides by 5 over 2, on the left side, the 5 cancels out with the 5, the 2 cancels out with 2, and you just end up with R on the left side is equal to 5/2 of S. And now you want to take 1/10 of that. So then you'll multiply by 1/10 on both sides, and that'll give you 1/10 of R is equal to, in terms of S, 5 and 10 cancels out, or the factor 5 cancels out. You have a factor of 2 remaining in the denominator, and S, remember, has a 1 as a denominator. So the numerator is just S, the denominator is 2 times 1 times 2, or 4. So 1/10 of R is equal to S over 4, or choice D. So here you have to isolate R, get R by itself, and then you can take or find 10% of that. And you'll have R in terms of S, which is choice D. You can also substitute in numbers here as well, and then just go through all the choices and just plug them in. All right, next for number 13, in the figure above, which of the following must be true? So here you have 2 triangles. So if you take a look at the smaller triangle, you have angles YR, and I'm missing this angle, so I can just call this A for angles. So you know that Y plus R plus A is equal to 180 degrees. And remember, all triangles, the angles add up to 180 degrees. And then for the larger triangle, it also has angle A, but now has X and Z. So then you'll know that X plus Z plus A is also equal to 180 degrees. And there's some symmetry here because both of these are triangles and they both add up to 180. So you know that Y plus R plus A has to be equal to X plus Z plus A. And because A shows up on both sides, you can subtract A from both sides. And you get that Y plus R has to be equal to X plus Z. So this is our starting point. So this is true. Now, I don't see that in the choices. I see them kind of, shuffled around there. So you want to see which ones you can, or how you can rearrange y plus r and x plus z into one of the choices. Now, because everything is positive, when you move stuff around, they'll turn negative. So our best bet is to look at the equations, the choices with the negative signs, because I don't see the positive version. So you might have to use negatives by rearranging. Specifically, if you take a look at choice D, when you have two negative signs, if you subtract z and you subtract r from both sides, you'll actually get choice D. So again, y plus r is equal to x plus z. If you subtract r from both sides, you'll be left with y is equal to x plus z minus r. Then if you subtract z on both sides, cancel out the positive z on the right, you'll have y minus z is equal to x minus r. So two negatives on both sides because we swapped two things around, and that's why the answer is choice D. X minus r is equal to y minus z. All right, next for number 14. If a prime fact number is a non-prime integer such that each factor of the integer other than 1 and the integer itself is a prime number, which of the following is a prime fact number? So just follow the word problem here. You have a non-prime integer such that each factor, so remember factor times factor is product. So each factor other than 1 is also a prime number. So you must have just prime factors. So basically do the prime factorization of these, or sorry, not the prime factorization, do the factoring of each of these numbers. So if you take a look at choice A for 12, you know that you can split 12 into, again, you ignore 1 and the integer itself because it's other than that. So you start with 2 and 6 and 3 and 4. Now 3 is prime, 2 is prime, but 6 and 4 aren't, so they're wrong. So choice A would be incorrect. For choice B, it's 18. You ignore 1 and 18, but you have 2 and 9 and 3 and 6. So again, 2 and 3 are prime, but 9 and 6 are not. So choice B is wrong. Go to the next one. Choice C is 21. You ignore 1 and 21. The other factors are just 3 and 7, both of which are prime. So the answer is going to be choice C. But go through all the choices just in case. 24, you have a whole bunch of factors for 24. And you ignore 1 and 24. You have 2 and 12. And 12 is not prime, so that tells you that 24 can't be it. But you have 3, which is prime, and 8, which isn't prime, and 4 and 6, neither of which are prime. So choice A is wrong. And then you also want to try 28. When you check, 1 and 28 doesn't count, but you have 2 and 14. Again, 14 is not prime. And 4 and 7. So just 2 is prime. Oh, and 7. But that's not all 4. So the answer has to be choice C. And just follow the rules. Next for number 15, if 3x plus y is equal to 14 and x plus y are positive integers, each of the following could be the value of x plus y, except. So here you have x and y that are restricted by positive integers, and integers are whole numbers. So there's a really big restriction here. For example, the smallest positive integer is 1. To make x equal to 1, that should be 3 times 1. And you know that 3 times 1 is 3. So 3 plus 11 has to be 14. So if x is equal to 1, y has to be 11. So x plus y could be 1 plus 11 or 12. To eliminate choice A. Then you try the next one. So if x is equal to the next number, which is 2, 3 times 2 is 6. 6 plus 8 has to be 14. So you'll have to do 2 plus 8 for x and y, and that's equal to 10. So choice B is wrong again. You're looking for one except. All right, next up, you have x is equal to 3. 3 times 3 is equal to 9. 9 plus 5 is equal to 14. So x is 3, y is 5. 3 plus 5 is 8. That's choice C. You eliminate that. And then next up, you try x is equal to 4. So you have 3 times 4, which is 12. 12 plus 2 is equal to 14. So you'll have 4 plus 2. That's a sum of 6. Eliminate choice Z. Has to be choice C. You can't get a sum of 4. It's probably going to be way too small. Okay, for number 15, just go through all the choices. There aren't that many pairs because you're restricted by the fact that you have positive integers. Again, integers are whole numbers. They could be positive, they could be negative, it could be 0, but they're the numbers that you draw on the number line. All right, next for number 16, a certain deck of cards contains R cards. After the cards are evenly distributed among S people, S cards are left over. So in terms of R and S, how many cards did each person receive? So when you distribute evenly, that's a key word, which means divide. So if you take R cards and you divide it by S people, get some quotient Q, and you have a remainder of 8 cards left over. Now, you don't care about the 8 cards. You want to know how many cards did each person receive? That's, of course, Q. Now, to get what Q is equal to, you'll have to use the inverse operation. Remember, the remainder is the result of subtracting. So if you take R minus 8, and then so if you take out the 8 cards first, and then you divide it by S, this will be equal to Q, the quotient. And this would be the number of cards per player. And that's going to be choice C. Now, the other way to do this is by just substituting in numbers. So pretend there are, 20 cards. And you distribute it to, 12 people. So everyone gets 1 card. There are 8 cards left over. Then you go through all the choices and see which one is equal to 1. But you can solve this algebraically or just by substituting in. All right, and here's the summary for this page. Okay, next for number 17, if D is an integer, which of the following cannot be an integer? So just go through all the choices. An easy integer you can use, again, just a whole number. 1, for example. So go through all the choices. Choice A, 1/2, that's not an integer, so maybe that's the answer. Choice B is the square root of 1/2. That's also equal to 1/2. That's probably not an integer. So that's not an integer, actually. So that could be the answer. Choice C is 2 times 1. That's equal to 2. That's a whole number. So we disprove choice C. Choice C could be an integer. Again, you're looking for one that cannot, which means can never be. And we found a scenario in which choice C was an integer, so that's wrong. Choice D is 1 times the square root of 2, and that's root 2, which is not an integer. Choice E is 1 plus 2, which is, of course, 3. That's a whole number, so that's wrong. Now, we're trying to disprove the choices that are remaining. For choice A, if you make D equal to any even number, let's say 2, 2/2 would be equal to a positive number, a positive whole number, 1, and that is an integer. So A is also wrong. For choice B, you have the square root. Now the square root could also make things a little more complicated, but if D were equal to, let's say, a perfect square, such as 4, 1 didn't work, but let's try even perfect square like 4, then the square root of 4 divided by 2 would be 2/2, which is equal to 1, which is the whole number. So choice B got disproven if D is a positive, even square, perfect square. So the answer has to be choice D. Now, D is a whole number, and when you multiply a whole number, a rational number, by an irrational number, like square root of 2, the square root of 2, this decimal never ends, and it also never repeats. So if you take a decimal that never ends, so it never terminates, and it never repeats, well, you'll never get a whole number out of that, no matter what number you multiply by, as long as it's a whole number. Again, D is a whole number. You can multiply an irrational number by any whole number in the world. That will never lead to a whole number. It's already a decimal. So the answer is choice D. All All right, next for number 18. In the figure above, the area of triangle ABC is 6. If BC is equal to CD, what is the area of triangle ACD? So here, remember the area of a triangle is equal to 1/2 base times height, where base has to be perpendicular to height. Unfortunately, this little box tells us that the base is perpendicular to the height. So the base, let's say, is AB, and let's make CB the height. 1/2 base times height is equal to 6 in this case. Now we know that BC is also equal to CD, so length of CD is also equal to H, and the base of CD, of triangle ACD, is actually of this this obtuse triangle. When you have an obtuse triangle, the height has to be an extended height that is perpendicular. So it turns out that for triangle ACD, you'll have to actually extend one of the edges, and that piece will be the height, or in this case, called the base. It doesn't really matter. So the areas will actually be the same because it's the same base and the same height, because again, they are equal. The heights are equal here. So the answer is going to be choice A, 6. You can also substitute in random numbers to see what the area is, but it will stay the same. All right, next for question number 19. The ratio of x to y to z is 3 to 6 to 8. Now, if y is equal to 24, what's the value of x plus 2? X plus z. So you have a ratio here, and a ratio is just like a fraction, except you write it a little differently. Use a colon symbol here. X to y to z is in a ratio of 3 to 6 to 8. Now, just like fractions, these numbers all have been reduced. However, you are given that y is equal to 24, so you'll replace this y in the middle with its actual value of 24. So you're going to want to essentially unreduce this fraction, and to do so, you can do 24 divided by 6, which is 4. So you have to multiply the 6 times the 4 to get 24, which is the unreduced fraction. And just like in a fraction, whatever you do to the numerator, do to the denominator. Here for a ratio, whatever you do to one of these quantities, you have to do all three. So you multiply everything by 4 to get the actual values. The actual ratio is 12 to 24 to 32. Again, you get that by multiplying 3, 6, and 8 by 4. Now you want to figure out the value of x plus z. So x is actually 12, z is 32. So x plus z is going to be 12 plus 32, which will be equal to 44. And that is choice C. You can also check your work by just by adding 3 plus the 8, the 3 parts plus the 8 parts, which is 11, and then multiplying that by 4. And 11 times 4 is 44, so everything does check out. Next for number 20, what is the minimum number of rectangular tiles, each 12 centimeters by 18 centimeters, needed to completely cover 5 flat rectangular surfaces, each 60 centimeters by 180 centimeters? So you're tiling some floors or 5 rooms or whatever. So here you have 5 of these flat rectangular surfaces, so just 5 rectangles, and these are 60 by 180. So this is really an area problem, and the area of a rectangle is length times width. So that's the formula we're going to be using. So here you have to multiply 180 by 60 to get the area. And you have to multiply that by 5. So the total area is going to be 5 times the area of one of these, which is 180 times 60. Now, don't actually multiply it out because we're going to end up dividing anyway. So if the tiles are 12 by 18, then you'll have to take the total area divided by the area of the tile. And the area of each of these tiles is going to be 18 times 12, again, using that same formula, length times width. And you'll have to divide both of these. The tile area divided by the total area divided by the tile area will be equal to the number of tiles that you need. Now, when you actually have these numbers, I'll have to do 5 times 180 times 60 divided by 18 times 12 in parentheses. You can cross simplify here. So 180 and 18 is the factor of just 10, has 18 in common. It's 18 as a common factor, and when you cancel out that 18, you end up with 10 in the numerator and just 1 in the denominator. Then do the same thing for 12. 12 and 60 are both in a 12 times table. They have a 12 in common, so when you factor out and cancel out that 12, you end up with 5 in the numerator. So this just boils down to 5 times 10 times 5, which ends up being 250. So that means that you need 250 tiles, and that's choice E. So here, the key was to divide the total area by the area of each of the tiles using this formula, length times width, for the area of a rectangle. All right, next for number 21. If x plus y is equal to 11, y plus z is equal to 14, and x plus z is equal to 13, what is the value of x plus y plus z? So here you have your system of equations with 3 variables and 3 equations. We can solve for each of them using either substitution or elimination. However, there is a shortcut here, because if you write everything out, x plus y is equal to 11, y plus z is equal to 14, and then x plus z is equal to 13. Notice that you have 2 instances of each of these variables. So if you add everything up, it's kind of like a variation of the elimination method. If you add everything up, you end up with 2x plus 2y plus 2z is going to be equal to 38. And then you can actually divide both sides by 2, because 2x, 2y, and 2z all have a factor of 2 in it. So when you factor out this 2, inside the parentheses, you'll have x plus y plus z left, and that's equal to 38. Then you can divide both sides by 2 to get x plus y plus z is equal to 38 over 2, or 19. So that's the shortcut method here. Choice D. You don't have to actually find what each variable is equal to. You know that the sum of all 3, x, y, and z, has to be 19, using this variation of this elimination method. And this only worked because we had 2 instances of each of these variables. So in this situation, it worked out really well. In other situations, you'll have to use either substitution or elimination to solve the system of equations. So just keep that in mind. All right, next for number 22. In the figure above, side AB of square ABDE is extended to point C. Now, BC is equal to 8, and CD is equal to 10. What is the perimeter of triangle ACD? That's this triangle here. All right, so here you have a square, and you know that all the angles inside a square are 90 degrees, so you can fill that in. Now, if you extend one of the sides of the square to point C, that means that it's just a straight line. You have the other side is also going to be 90 degrees, because 90 plus 90 is 180. This has to be a straight line, and a straight line has to be 180 degrees. They're supplementary. So you know that angle DBC here also has to be 90 degrees. So that means that triangle DBC is a right triangle. And here, for a right triangle, you can use Pythagorean. And Pythagorean theorem states that a squared plus b squared is equal to c squared. But here, there's a shortcut as well. If you notice the numbers 8 and 10, this is one of your triplets, your Pythagorean triplets, specifically a 3, 4, 5 right triangle, but each side doubled. So this is a 6, 8, 10 special right triangle. So you have 8, which is 4 times 2, 10, which is 5 times 2. So then side BD is going to be 3 times 2, or 6. So this is your 6, 8, 10 special right triangle. And that tells you that the square, since all the sides are equal in a square, all these sides are going to be 6. And now, when you have this diagonal inside the square, you make another special right triangle. This one's called a 45, 45, 90 special right triangle, or an isosceles right triangle. And the sides are on the ratio of x, x, and x root 2. You can also just use regular Pythagorean for that, if you forget. But that's a whole bunch of steps. Since the sides are 6, you know that x is equal to 6. The hypotenuse is going to be 6 root 2, and that's what you want. So here, to get the perimeter, which is all the sides added up, for triangle ACD, you need 6 root 2 plus 10 plus 8 plus 6. And 10, 8, and 6 are like terms. They combine to form 24. So this turns into 6 root 2 plus 24, or choice B, 24 plus 6 root 2, just using the commutative property. So here the key was to use Pythagorean, which states that for all right triangles, a squared plus b squared is equal to c squared. And that's always true. Now, the shortcuts are the Pythagorean triplets. So the 3, 4, 5 triangle are just 3 nice numbers that satisfy Pythagorean. You also have your 5, 12, 13 right triangle as well. Those are the special right triangles, and their multiples, and these you have to memorize. Now, the other piece of info that you needed was an isosceles right triangle, or 45, 45, 90 triangle. Sides on a ratio of x, x, x root 2. If you forget that, that's fine. You can also just use Pythagorean, but just know that it takes a couple more steps. All right, next for number 23. If r is less than 0 and parentheses 4r minus 4 squared is equal to 36, what's the value of r? So r less than 0 means that r is negative. And here you have 4r minus 4 squared is equal to 36. So what you can do is take the square root on both sides. But be careful when you do this, because when you take the square root of both sides, you actually end up with 2 potential answers. 4r minus 4, which is what's left over after that square root cancels out with that power 2, can be equal to positive 6, or 4r minus 4 can be equal to negative 6, because positive 6 squared is 36, but negative 6 squared is also 36. So once you have these 2 equations, you can solve for it just by using inverse operations. You have to add 4 to both sides. You get 4r is equal to 10, and when you divide by 4, you get that r is equal to 10 over 4, which simplifies to 5 halves. Now that's positive, and we know that r has to be negative, so we eliminate this. Now for the other side, to solve for r, you have to add 4 on both sides. You get that 4r is equal to negative 2. Then when you divide by 4, you actually get a negative number. R is negative 2/4, or negative 1/2. So that's going to be choice C. So that makes sense because we know that r has to be negative. Now you can also check your work here by substituting in. If r is equal to negative 1/2, substitute that in for r. So instead of 4 times r minus 4, you have 4 times negative 1/2 minus 4. This whole thing is being squared. I want to see what this is equal to. Well, 4 times negative 1/2 is negative 2. And negative 2 minus 4 is equal to negative 6. And negative 6 squared is positive 36, because negative times negative is positive. So everything does check out. We know that r has to be equal to negative 1/2. All right, next for number 24. 5 liters of water were poured from tank A into tank B, and then 10 liters of water were then poured from tank A into tank C. If A originally had 10 more liters of water than tank C, how many more liters of water does tank C now have than tank A? So we have 3 tanks. And you know that 5 liters of water were poured from A into B. So now, B has 5 more, and A has 5 less. And then you're not done though, because you also pour 10 liters of water from A into C. Now, originally, A had 10 more liters of water than tank C. So if we call C, for tank C, origin has C liters of water, A would have C plus 10. Now, if you pour out 5 and pour out 10, A now has C plus 10, that was its original, minus 5, and now you minus 10 as well. And positive and negative 10s cancel out. So now A has C minus 5 liters of water. C, on the other hand, started out with C liters, but then you added 10 more liters because you poured 10 liters from A to C. So now you have C plus 10. And the difference between these two quantities, C minus 5 versus C plus 10, is equal to 15. There's a 15-liter difference from negative 5 to positive 10. So the answer is going to be choice D, 15. You can also start with random numbers. For example, if you check your work. So you know the only requirement, the only restriction is that if, let's say, C has 10 liters of water, A must have 10 more than C. So A will have 20. Now you pour 5 from A to B. So now let's say B had 0 in the beginning, doesn't really matter. Now B has 5. Instead of 20 liters, now it only has 15 liters now. But then you pour another 10 to C. C will now have 20, whereas A will now have only 5. And the difference between 5 and 20 is choice D, 15. So that's how you can check your work, just by substituting in a test number and then just trying it out. All right, next for number 25, if a cube has a surface area of 36 n squared square feet, what is the volume in cubic feet in terms of n? So the surface area for a cube has a formula of 6s squared. If you take a cube and you open it up into a net diagram, you actually end up with something that like this, where you have 6 squares. And since each side is s, the surface area is going to be 6 times s squared. And the volume of the cube is, of course, s cubed. So you can just set 6s squared equal to that 36n squared that's given. And here you want to solve for the side. So to solve for s, because you want to know what the side is, you can divide by 6 on both sides. And that will give you 6n squared is equal to s squared. And then you would have to do the square root on both sides. So you get that s is equal to the square root of 6 times n. Here you can actually split this square root into 2. That's one of the laws of exponents. The square root of a times b is equal to square root of a times the square root of b. So you can cut square roots and radicals in half. Now, since we know the side, we can substitute back in to find the volume. So the volume is side cubed. So that's going to be n times root 6 to the third power. And now you can use this law of exponent that states that if a product both being raised to the same exponent, this is kind of like the distributive property, you'll distribute that exponent across each of the quantities inside the product, inside the parentheses, I should say. So here, this power of 3 will apply to the n and the 6. So you end up with n cubed times the square root of 6 cubed. And now the square root of 6 cubed you can rewrite as square root of 6 times square root of 6 times square root of 6. Now, root 6 times root 6 is equal to 6. So you have n cubed times 6 root 6. Or you can rewrite this as choice B, 6n cubed root 6. If you just rearrange the quantities there, just using the commutative property. All right, and here's a summary for this page. All right, next for number 1, if 2 times x plus y is equal to 8 plus 2y, then x is equal to. So here, the first thing that you want to do is to distribute. So this is the distributive property of multiplication. So you'll do 2 times x, which is 2x. and then you'll be adding 2 times positive y, or 2y, and that's equal to 8 plus 2y. So of course, the 2y is the same as a 2y, and the 2x, that's just a different color, the 2x has to correspond to the 8. And we want to solve for x. So 2x has to be equal to 8. When you divide by 2 on both sides, you get that x is equal to 4. And that's choice D. Next, for question number 2, from the number line above, what is the distance from point B to the midpoint of AC? So the midpoint is just the middle, and the middle of 2 points is just the average. So it's the sum divided by the number of data. In this case, the 2 points are A and C, so it's 1 and 7. So 1 plus 7 is 8. You just want to divide that by 2. That's equal to 4. So that means that 4 is the midpoint. We can call that M. So you want the distance from point B to the midpoint, or M. So this distance is just 4 minus 3, or 1. That's choice A. Next, for question number 3, a certain machine caps 5 bottles every 2 seconds. At this rate, how many bottles will be capped in 1 minute? So you have 5 bottles in 2 seconds. And you want to know how many bottles, X bottles, in 1 minute. Now, 1 minute, you know, is equal to 60 seconds. I want to make sure our units are the same. That way, when you set up the proportion here, you can officially cross multiply. Again, the units have to be the same before you can do that. So you have 5 times 60 is equal to 2 times x. Then if you divide by 2 from both sides, you get that x here is equal to 5 times 30, or 150. So that's going to be choice C. So you can set up your proportion and then just cross multiply and solve. Next, for number 4, if 2n plus 3 is equal to 5, then 4n is equal to. So let's try to solve for n, or at least 2n here. You can do that by subtracting 3 from both sides. You end up with 2n is equal to 2. Now I don't want 2n, I want 4n. So you can just double both sides. And 2n times 2 is going to be equal to 4n, and 2 times 2 is going to be equal to 4. You can also solve for n is equal to 1, and then just multiply that by 4, and you get choice C. All right, next, for question number 5, if a plus b is less than 5 and a minus b is greater than 6, which of the following pairs could be the values of a and b? So here, you can have a lot of potential cases. So just go through all the choices, and you want to make sure that you satisfy both. So the sum of these 2 points has to be less than 5. So for choice A, you have 1 plus 3. That's equal to 4. That's less than 5, so that's okay. For choice B, 3 plus negative 2 is equal to 1. That's less than 5, so that's fine. For choice C, 4 plus negative 2 is equal to 2, and that's less than 5, so that's good. For choice D, 4 plus negative 3 is equal to 1, which is less than 5, so that's okay. And then 5 plus negative 1 is equal to 4, which is also less than 5. So this was useless for us because it didn't eliminate any of the choices. Now, you have to use the other part. Hopefully 4 of these will be eliminated. So a minus b has to be greater than 6. So for choice A, you have 1 minus 3. That's equal to negative 2. That's not bigger than 6, so A is wrong. For choice B, 3 minus negative 2. Again, you have to subtract a negative. That means it's the same as 3 plus 2. That's equal to 5. That's still not bigger than 6, so that's wrong. For choice C, 4 minus negative 2 is equal to 6. Now, 6 is not greater than 6, so that's wrong. For choice D, 4 minus negative 3 is equal to 7. 7 is greater than 6, so this one is good. But go through all the choices just in case. For choice E, 5 minus negative 1 is also equal to 6, which is not bigger than 6. So the answer has to be choice D. Again, just substitute all the choices in and then figure out what the potential answers could be. All right, next you have this triangle above. Again, if we're not drawing a scale, the measure of angle B is 60 degrees. Then what's the value of y? So here, angle B is given as 2x minus 4, and you're given that this is equal to 60. So to solve for x, you'll have to use inverse operations. First, add 4 to both sides. That cancels out the negative 4, and you end up with 2x is equal to 64. Then the opposite of multiplying is dividing, so you'll divide by 2, and you get that x is equal to 32. Again, that's not the answer because we want to solve for y. So if x is equal to 32, you'll have to figure out what all these angles add up to, or what each of these angles are. So for for angle B, it's 2 times 32 minus 4, or 64 minus 4, which is equal to 60. For angle A, it's 3 times 32, which is equal to 96. And you have y. Now here are the three angles in a triangle has to add up to 180 degrees. So you end up with an equation, 96 plus 60 plus y has to be 180. And here 96 plus 60 is 156. So 156 plus y is 180. If you subtract 156 from both sides, you get y is equal to 24 degrees. And that's choice A. So here you have to solve for x, then substitute x back in to get the two angles, and then use this fact that the three internal angles in a triangle add up to 180 degrees to solve for y. Next, for number 7, in a certain building there are 10 floors, and each number of rooms on each floor is r. If each room has exactly C chairs, which of the following gives a total number of chairs in the building? So here you have this building, there are 10 floors, and the key word here is each. Each floor has R rooms, so if you have 10 floors, R rooms each, that will give you 10 R rooms total. Now each room, again, each means to multiply or divide, but in this case it's multiply because you want the total. Dividing wouldn't make sense here. So again, each of these rooms has C chairs, so you'll have to take these rooms times another C chairs to get 10 RC, which would be equal to the chairs in the entire school, and that's choice D. Now, the other way to do this question is to substitute in some numbers. For example, if you have 10 floors, and each floor has, let's say, 5 rooms, and in each room has 2 chairs. So R is equal to 5 and C is equal to 2. To figure out the entire number of chairs in this entire building, you'll have to do 10 times 5 times 2, or 100. So that's a magic number. You have to go through all the choices here to figure out which one of these is equal to 100, and only choice D should be equal to 100. Now, sometimes if you do this method and you see that 2 of these choices give you the same result, you'll have to substitute in a new set of numbers to use this process of elimination to figure out which one is your answer. Because sometimes when we choose really nice numbers like 2, 5, 10, 20, whatever, the choices might just coincidentally have the same numerical number or numerical output. So you might have to substitute in more than one set. So just be wary of that. All right, and here's the summary for this page. Okay, for number 8, if the sum number is defined as one in which the sum of the digits of the number is greater than the product of the digits of the same number, which of the following is a sum? So here you just have to follow the rules. Here you want the sum to be greater than the product. So remember, sum is adding, product is multiplying. So you have to look at the digits and you have to do the sum first. So just go through all the choices. For choice A, you do 1 plus 2 plus 3, that's equal to 6. For choice B, it's 2 plus 3 plus 4, which is equal to 9. For choice C, it's 3 plus 3 plus 2, which is equal to 8. For choice D, is 4 plus 1 plus 1, which is equal to 6. And then for choice E, it's 5 plus 2 plus 1, which is equal to 8. And now you want the sum to be greater than the product. So the product for choice A is 1 times 2 times 3, and that's equal to 6. Now 6 is not greater than 6, so that's wrong. For choice B, you have 2 times 3 times 4. That's going to be 2 times 3 is 6. 6 times 4 is 24. That's, again, not less than 9. So choice B is wrong. Can you look? You want the one where the sum is greater. For choice C, it will be 3 times 3 times 2, which is going to be 9 times 2 or 18. Again, 8 is not bigger than 18, so that's wrong. For choice D, you have 4 times 1 times 1, which is just equal to 4. And 6 is greater than 4, so that's probably the answer. But still got to go through all the choices just in case. For choice E, it will be 5 times 2 times 1, which is equal to 10, and 8 is not greater than 10. So choice E is wrong. So the answer has to be choice D. Next, for number 9, if 4% of R is 6.2, then 20% of R is... So you have 4% of R. Here you have to turn the word sentence to number sentence. Of means multiply. So 4% times R, and is means equals to. That's equal to 6.2. Now, you don't want 4%, you want 20% of R. So that's going to be 20% times R. So if you take a look at the product here, you have to multiply 4 times 5 to get 20. So then that means on the other side, you also have to do 6.2 times 5 as well. And you have to move the decimal one place. I'm sorry, that's 31. You have to move the decimal one place over. So the answer is going to be 31. And that's choice D. So you don't actually need to solve for R here. You can just turn the word sentence to number sentence and then just multiply both sides by 5. Next, for number 10, at a certain school, if the ratio of the teachers to the students is 1 to 10, which of the following could be the total number of teachers and students? So here, the ratio of teachers to students, so T to C, is going to be 1 to 10. And now both of these are parts. If you want the total, of course, is the sum of the two parts. So it's going to be 1 plus 10, or 11 parts. That means that the actual number, the actual total, has to be some multiple of this 11. Because there are 11 parts, and you can't have, half of a person, you know that the actual number of people in this entire school has to be a multiple of 11. So just scan through all the choices. Only choice B is a multiple of 11. 121 is 11 times 11. So that could be the total. Now you can also check your work here. If 121 is the actual total, you know that 11 times 11 is 121. So that means that if you multiply each of these parts by 11, you'll have 11 teachers to 110 students. And that makes sense. Because here, 11 is a whole number, 110 is a whole number, and the ratio here is 11 to 110, which simplifies into 1 to 10. And the total, of course, is a multiple of 11, so the answer is going to be choice B. All right, next for number 11, if x arrow or symbol y is defined by the expression x minus y to the x power plus x plus y to the y power, what's the value of 4 symbol 2? So this little symbol here, for this question, it's your function, and a function is just an input-output machine. So what that means is you just gotta follow the rules here. All right, so to follow the rules for this input-output machine, in this case, you have 2 inputs, and you get this rule here, just follow that, and then you get your answer. So 4 symbol 2 is gonna be where x is equal to 4, y is equal to 2. So just replace all the x's with 4, and then all the y's with the number 2. and then just evaluate. So for symbol 2, this expression would actually be 4 minus 2, x minus y, raised to the x power, which is raised to the 4, plus, parentheses, 4 plus 2 raised to y, or raised to the second power. Now to simplify this, 4 minus 2 inside the parentheses, you have to do, of course, order of operations. Please excuse my dear Aunt Sally. So you got to do parentheses first. So 4 minus 2 is, of course, 2. And then 4 plus 2 is 6. So we're done with parentheses. Next up are the exponents. So don't add yet, you got to do the exponents first. So 2 raised to the 4 power. Remember, this is 2 times 2 times 2 times 2. It's 2 times itself 4 times. That's going to be 16. And then 6 squared is 6 times 6, or 36. And finally, there's no multiplying and dividing. So then when you add and subtract left to right, so then you finally add 16 plus 36 is 52. And that's going to be choice A. So here you actually have a function question, and the function is just an input-output machine. Just follow the rules here. Substitute or replace each of the variables with the actual numbers. In this case, x is equal to 4, y is equal to 2. And then just use the order of operations. Please excuse my dear Aunt Sally to help you solve for the expression. All right, next for number 12. In pentagon ABCDE shown above, each side is 1 centimeter. All right, if a particle starts at A, so right here, and it travels clockwise, so clockwise just like the hands of clock, moves to B, then C, then D, then E, and it does 723 centimeters along ABCDE, the particle will stop on which point? So here is kind of like the hands on this weird clock are just moving forward 723 times. Now, obviously, you don't want to count up 723 times. You want to look for a pattern. Look for that repeating pattern. And in this case, you know that one full circle, one rotation is equal to 5 centimeters. If you go around exactly once, you end up right back at A. And that's 5 centimeters. So every 5 centimeters, you'll end up at A. So that's the pattern here. If you end up at A every 5 centimeters, you can actually just divide 723 divided by 5. And instead of actually looking for the quotient, we actually just want the remainder. And you actually know the 5 times table has to end in 0 or 5. So what you're really looking for is 720 divided by 5. You get some, whole number, some whole number quotient. And that means that 723 divided by 5 will have a remainder of 3. You actually want the remainder here. So this remainder of 3 is actually really important because after you move 720 centimeters, you end up at A again. Because 720 is a multiple of 5. Every 5, every 10, 15, 20, 25, 30, 35 centimeters, whatever, you always end up at A, and 720 ends in a 0, so you know it's on the 5 times table. After you go around 720 centimeters, you're back at A. Now, that remainder of 3 tells you have to move forward 3. So you'll have to go forward once to B, another one to point C, and then you end up at point D, because that's 1 plus 1 plus 1. And that means that the answer is going to be choice D. That remainder is the key here. All right, for these pattern questions, once you figure out the pattern, you have to do the quotient after you divide. You don't actually care about the quotient. You actually care about the remainder. You would have to go forward that remainder in that pattern because it won't complete the entire circle. We'll do a part of the circle, and you'll end up at point D. So the answer is choice D. So the key here was to really look for the pattern. And the pattern was that every 5 centimeters, you end up at A. And then just divide and focus on the remainder. All right, next one, number 13. Which of the following values of s would yield the smallest value for 4 plus 1 over s? So here, s is in the denominator, and you want to minimize this expression. So if you want to minimize 4 plus 1 over s, well, you can't do anything about the 4. To minimize this fraction part, you know that the bigger the denominator, the smaller the overall fraction. Because the denominator, if you have a really large denominator, let's say 100, that's like cutting a pizza into 100 pieces. Each piece would be really, really small because you're cutting into so many pieces. So the larger the denominator, the smaller the overall fraction. So since s is in the denominator, that means you actually want to maximize s. If you maximize s, you'll actually minimize the overall fraction, which allows you to minimize this expression. So scan through all the choices. Choice E is the largest. So that's going to give you the smallest value. And you can test it out. If you replace s with 4, you have 4 plus 1/4, or 1/4, which is 4.25. If you go to, let's say, choice D, 2, that's 4 plus 1/2, or 4.5. That's 4.5, or really 4.50. That's, of course, bigger than 4.25. And if we go on the other end of the spectrum, for choice A, 4 plus 1 over 1/4 is actually 4 plus 4, which is equal to 8. That's the largest. When you're dividing by a fraction, you have to keep change flip. So 1 divided by 1/4 is really, you do keep change flip, 1 times 4 over 1, which is equal to 4. So this ends up being 4 plus 4, which is 8. All right, and here's the summary for this last page. All right, thank you everyone for joining me today. Enjoy the rest of the day, and I will talk to you guys in the next one. All right, bye everyone.